continue with the Secretary of Humanity Plus. He's David Wood, a person that I greatly admire. As probably most of you used a Nokia when you were young and beautiful. He developed the Symbian system that was acquired by Nokia, the first operating system I guess we had in humanity. He studied at Cambridge University. I also studied in Cambridge, but Cambridge, Massachusetts, the competition. And he is the Secretary of Humanity Plus, Chair of London Futurist, and let's hear about accelerating artificial intelligence.
So I will make my remarks build on top of what you heard, that remarkable presentation by Ben and Sophia. My name's David Wood. If you want to criticize me on Twitter or find out more what I say, you can find me at DW2. My background was in the smartphone and mobile computing industry, and I will share some comparison between that industry and the artificial intelligence industry. But for the last 10 years, I have been chairing London Futurists. We've had more than 200 public meetings in London where the subject of the future of AI has often been discussed. But today, we are in Madrid, and we are thinking about the future of artificial intelligence. How much impact might AI have on the world by, let's say, 2035? That's 17 years in the future. And what futurists do, what professional futurists try to do, is not just look at the future, but look at the past to see how people made forecasts in the past and what we can learn from that. So I'm going to imagine another forecast made in another city, New York, in the year 1983, when a bunch of clever people were asked to predict the impact by 2000 of mobile phones. They were looking 17 years into the future as well. And in 1983, this was perhaps the state of the art in mobile phones. You may have seen this before. This came from a strange, unknown company from Finland. And this was Nokia's first mobile phone, the Mobira Senator. It was a heavy device. It weighed about 10 kilograms, and you couldn't hold it for very long before you got tired. And people said it didn't matter that the battery didn't last very long because you couldn't hold it very long. It was designed for use, in fact, in or near cars. And some big companies were very interested in these strange new devices, and AT&T, who did phones, they did fixed line phones in America. They wondered, do they need to change their business on account of these new strange mobile phones? And they asked some very clever people from McKinsey based in New York, do you think we have to change our business because of this new product category? And the people in McKinsey were clever. They'd seen the future. They'd watched Star Trek. They knew that by 300 years in the future, there would be these amazing communicators. And they thought at some stage mobile phones might get a bit better than these clunky, heavy, power-hungry mobile phones from Nokia. So they said maybe there might be almost 1 million people using them by the year 2000. And the AT&T people said, well, thank you for telling us that. That means we don't need to change our business priorities. This is an insignificant small market. We can keep on doing what we love doing, which is fixed line phones. Now, AT&T is still here today, but it's a very different company. It's not quite the same company. That original AT&T basically went out of business because that was a very bad prediction. They predicted 0.9 million. The actual answer was 3 orders of magnitude bigger, 738 million worldwide. Oops. And you can get McKinsey and other consultancies today to tell you, you don't need to worry about artificial general intelligence. It's going to take hundreds of years to become significant. And they would be equally wrong as the consultants in McKinsey who were doing what AT&T wanted them to do, tell them it wasn't really important. Mobile phones grew and grew, billions, getting lighter, lower cost, more useful. And to be fair, it is hard to predict how far you can get with sustained innovation when you get a positive feedback cycle. In case any of you are not quite following this, in my analogy, that clunky Nokia mobile phone is the same as Sophia, and Nokia is playing the role, perhaps, of Hanson Robotics. There's more to tell of this story. If you ask an American who invented the mobile phone, they'll say it was Motorola, and this person in particular, Marty Cooper. This is a photograph of him making the first public phone call from a mobile phone in 1973, but it wasn't yet a commercial reality. It took Motorola another 11 years to turn that product concept into something they could sell in 1984. And if you think 11 years is long, let's go back to the original concept designs made in AT&T Bell Labs, as it happened, in 1947. It takes a long time to develop product concepts into something that's a commercial, successful reality. And that initial device, by the way, wasn't very cheap. It was nearly $4,000 a time. And Motorola had to spend an awful lot of money. They spent $100 million before they get any significant returns. And they were eventually very successful as a result of that. Let's draw the pattern. Disruptions which change the world dramatically often take a long time to get going. This is the exponential curve of a new platform. And when the new platform starts, you get excited people like me and Ben Goertzel and Jose Cordeiro saying it's going to change the world. But most of the world isn't so excited, and there are simpler, easier ways of doing most of the same thing. Like AT&T thought people will keep on using fixed, simpler wired phones. Because the new technology, although it's architecturally interesting, technologically sophisticated, is not very usable, it's very expensive, and for a long time there aren't apps or services to make it worthwhile. But eventually it breaks through. Sometimes we talk about reaching the knee of the exponential. That's a strange and misleading term, but there's a tipping point. And then if you're on that old trajectory, like AT&T, you get left behind. And there's a summary of this called Amara's Law, after one of the pioneers of futurism, who said, we tend to overestimate the effect of a technology in the short run. We sometimes get too excited about what is going to happen in the next few years, but we underestimate the effect in the long run. Likewise, we tend to overestimate, some of us, what stem cell therapies might do in the short run, but underestimate what stem cell therapies are going to do in the long run. We tend to overestimate what AI is going to do in the short run, but underestimate the effect in the long run. Let's continue this story. 25 years ago, I didn't have futurist or transhumanist or singularitarian on my business card. I had software architect. I was working in this company, Cyan, that was making mobile computers, which were sort of state of art at the time. And we were doing three things, which all good companies should be doing. We were looking after the present product. I was involved in helping to translate the software into Spanish and into Finnish and so on. We also did an incremental improvement inside our own world, inside our own platform. We built a much better version of the same product. I still carry one with me today, one of these Cyan Series 5s with a better screen and better apps and better operating system. But we knew actually that our world was going to be impacted and disrupted by an elephant, namely the mobile phone industry, which by 1998, when this picture was drawn, was going at huge pace. It already was very successful. Our own world, Cyan's world, saw that computers were becoming smaller and more mobile. We realized that our world would be turned upside down by the mobile industry also being interested in similar products. And we decided, let's collaborate. Let's build a platform for collaboration based on the software running in these old devices. Let's make it a bit more mobile friendly, a bit more wireless friendly, putting in more features for email and web browsing. building a positive feedback cycle. That picture's not bad for the year 1998. We could spend a long time discussing what was right and what was wrong about it, but as a good stab in the future, it wasn't bad. Except we got some of the timescales wrong. And allow me to talk through some of the facts and figures, not because there's any quiz. I won't ask you afterwards what these figures were, but it's the pattern that's important, because the same pattern, I believe, applies to all of the technologies that are going to change the world of transhumanism. We thought in 1998 we would be profitable in 3 years. We got a lot of money from the main phone companies on that basis. We would create something for them. A funny thing happened on the way to profitability. There were environmental problems like the dot-com crash, and like lots of money being diverted into 3G networks instead of onto innovative new devices. It took us 3 major additional rounds of investment, in part because, to be frank, the problems we needed to solve to make our software work on good mobile phones were harder than we had expected. There were big technical problems we needed to solve. But eventually, by 2006, 8 years after we'd started, we were very profitable. We sold 100 million smartphones running our software, compared to, at the most, we only sold 1 million of these. And by the way, we had spun out this company, Symbian, to do this. After another 18 months, we had sold another 100 million. You can see the acceleration, a slow start and a speed up of the impact. And after another 3 years, yet another 300 million. And if the story would stop there, I should be pretty proud, because software written by my teams and by my colleagues were now on 500 million smartphones. But if you know the history, by this stage another big elephant had turned up, another big disruption, not this time the mobile phone industry, but Silicon Valley had finally got mobile technology, and by this time Apple's iOS and Google's Android had disrupted our space, and they were selling the most high-profile, most profitable phones. We weren't the only victim of that disruption. If you go back 12 years ago, I was at my first TransVision in Helsinki, as it turns out, and at that stage, software that my company had created was at the top of the world, along with other giants of the time, BlackBerry, Palm, Motorola, Nokia, and Symbian. We were all at the top of the world doing very well, and today all of these companies are almost nothing. They were transformed by the big disruption, the second wave. Let's put that on the picture, and then I'll draw the conclusions. Here's the phase 1 world of smartphones with BlackBerry, RIM, and Nokia, and so on. We took a long time, as I explained, to displace the feature phones, just as the feature phones before them had taken a long time to displace the fixed-line phones. And after a while, we were also, after a long time, displaced by the next wave of smartphones. Some people think the iPhone came out of nowhere. In reality, Steve Jobs and Apple went through many failed experiments with phones before they produced the first successful iPhone. And it's the same with Google's Android. Google's Android was created before being absorbed by Google back in 2003. It took them 7 years to reach sales of 10 million units a year. So the conclusion I draw here, the future arrives in waves, and often the new wave is surprisingly slow in the beginning before being very fast. Another conclusion I'll draw is in each new wave of these phones, software became increasingly important. In the feature phones, maybe if you were lucky, you might play a game called Snake, have some simple contacts management. In the next phase, there were mini computers in their own right with lots of significant software, including web browsing and agendas and word processing. But the more recent phones have got more power in them. A single one of these phones has got more power in them than all the computers used by NASA to send Apollo 11 to the moon and back. So it's no wonder that they have a big step up in software. So the second conclusion about how technology changes the world is that increasingly software eats the world. To quote Mark Andreessen, the web browser pioneer who's now a leading venture capitalist, by which he means in every industry, if you're not on top of software, you're likely to be outcompeted. And I want to give that a twist. I think in the not too distant future, people will say instead, software written by AI will eat the world. And if you're still relying on humans to write your software, you're going to be outcompeted in the next wave. Just one more demonstration that technology has got so much more power in the world now than before. If we look at the last 20 years or so, which companies at various times were the most valuable, for most of that time it was a mix of different kinds of companies like GE, a manufacturing company, or some oil companies like Exxon, or financial companies like Citi, with a few high-tech companies in there. But for the last 3 years, the most valuable companies have all been ones with a great focus on software and a great focus on AI. Software is eating the world. And even since that time, things have moved on. Apple's valuation there in 2016, 580 billion. It's now more than 1 trillion. Amazon's valuation, about just under 400 billion. Recently, it too has gone beyond 1 trillion. Software is eating the world. Is Amazon profitable yet? Here's the richest man in the world, Jeff Bezos. For a long time, they weren't profitable. For a long time, people said, this is never going to be significant. It's a waste of time. But now look, 12 straight quarters of incredible-sized profits, which explains their recent surge in value. But enough about the past. I want to look more now to AI. I want to draw the same kind of graph, but looking at different kinds of AI. I'm going to start off with good old-fashioned AI, sometimes called your grandfather's AI. It's when humans program lots of rules into the software to make it an expert lawyer or an expert calculator of some sort or other. If you taught that kind of software how to convert from one language to another, you had to teach it all the rules of language, all the grammar, all the declensions, all the special cases, and all the special cases of the special cases. And people thought there is an easier way to learn. For example, if I ask you, let me look away for a second. If you still see the pictures at the top there, what kind of animals in these pictures? At the very top, not in my slides, but in this wonderful building. You might see, and you recognize, oh, that's a lion, I think. How do you know it's a lion? Well, it just looks like a lion. If I ask you to give the rules how you know that's a lion and not a dog, you might say, well, it's a lion because it's got a mane. And I'll say, do all lions have manes? And you say, no, well, there's some special cases. And that's what expert systems have got to deal with. Whereas children learn just by looking at lots of things. So from the 1970s, expert systems were quite successful, but people always thought there'd be a better way to teach AIs how to learn. Just give it lots of examples, and it could learn by looking at the examples. So give it millions of pictures of lions, millions of pictures of dogs, and it will figure out by itself what the difference is by something called neural networks. And for a long time, that wasn't very good. For a long time, it only worked in rare cases. But from 2012, the world changed, and people who were still stuck on the old way of doing AI increasingly got left behind. What happened in 2012? Well, there was enough big data around for meaningful training sets. There were also improvements in the hardware. Instead of using old-fashioned CPUs, like at the heart of most PCs, there were newfangled things called GPUs, graphics processing units, developed so that teenage boys and grown-up teenagers could play graphics games on their PCs with lots of parallel processing. It turns out that's just great for doing deep learning. And by the way, people improved some of the algorithms too. It meant that computers could look at pictures like this, and in the past they would struggle to say much. They would say, I think there's a lot of green there, maybe some other kinds of green as well. From 2012 onwards, you could look at a picture and say, this is a group of young people playing a game of Frisbee. Much more precise. Now, that's just one example, but I can tell you about actual competition that's held every year or every 2 years, a bit like the Olympics, but it's held for bits of software. And they are given lots of pictures, and they are asked to give their best description of the pictures. They are asked to pick between various descriptions, which is correct. And you can see how this has changed. This is called LSVCR, the Large Scale Visual Recognition Challenge. And since 2010, the software wasn't very good. It was getting at least 1 in 3, about 1 in 3 wrong. Now it gets only 1 in 40 wrong. And the big improvement was in 2012, which is when a team from the University of Toronto applied these deep learning systems, got much better results than anybody anticipated, and from then on, every team used that software. And that software is now up at superhuman level. It makes less mistakes in interpreting pictures than we humans do. And this is being applied in multiple different practical fields, interpreting what's in a road sign, how accurate can you as a human make sense of all of these road signs. In a recent test, humans got about 1 wrong in 100. I think that must be a very good human. If I was in a hurry, I'd probably get more than 100, 1 in 100 wrong. But the software using a neural network, a so-called convolutional neural network, was twice as good. And by the way, it was 6 times as good as the best software program, the old-fashioned way in which you would actually teach the software by lots of rules. If it looks like this, it's probably this kind of sign, except if it looks like this, in which case it might be this kind of sign. Big improvements with convolutional neural networks. It's transforming the world of medicine. This is a part of a scan of some cells. The question is there cancer here or not? Google have colored it in helpfully. This is what you might be able to spot, that there is a tumor in this. There's also something that's not cancerous but might look like a cancer. It would be a false positive, a macrophage. Expert human pathologists who are given these huge big slides, this is only a small part of one, over the course of 130 hours with 30 slides, they got 73% right in detecting, whereas AI in this case got 89% right, running much faster.
And how much faster?
I'll give you that in the next case. I don't have the data there, but I have the answer in this next case, which is AI versus lawyers. Any lawyers in the room? Some of my good friends are lawyers. In this case, it was looking at one particular thing lawyers are asked to do, which is to evaluate NDAs, non-disclosure agreements. When somebody you want to do business with a company, often you're asked to sign an agreement that says you won't share their secrets. But sometimes these NDAs are quite tricky, and if you're not careful, you end up promising all your ideas to them as well. So when should somebody sign an NDA, and when should somebody query it? So there's a big database of NDAs as well, and these are 5 real-world NDAs, non-disclosure agreements, with 11 pages of densely written text, 153 paragraphs, 3,000 clauses to consider, of which it turns out that there were 30 clauses which a good lawyer would ask you to query before you signed it. So who did best in this? The AI that was taught by looking at lots of NDAs, or the real-world lawyers who had many decades of experience? The lawyers did not bad, 85% of the things they found, whereas the AIs, well, they were on average 3 times better. The lawyers took 92 minutes on average to scan these documents with their 11 pages and 3,000 clauses. The AI took 26 seconds. It was more accurate and was much faster. So field after field is being changed. That's just today's AI. That's what is happening with deep learning. What we transhumanists are really interested in is the next waves of AI. And to an extent, we can't say what they are because they haven't happened yet, but we do have ideas. And it's likely that they're going to be even more disruptive and change even more things at some stage in the next 20 years, perhaps 10 years, perhaps 5 years. Just one example of something that is very promising. It's not quite a new field in its own right. It's a special case of deep learning called adversarial networks. This has been described by Yann LeCun, who's the head of AI at Facebook. He also is one of the godfathers of deep learning himself, going back to work in the 1980s in this field. He said these generative adversarial networks are the most interesting idea in the last 10 years. What it's involved is 2 different networks. One of them's trying to outwit the other one in some sense. It's a bit like forgers. A forger may want to create fake money, and the police at first are quite easy to spot the fake money. Then the forgers get better at deceiving the police, and the police get better at spotting the forgeries, and so on it goes. So in this case, one network is generating fake pictures of humans, They're not real humans, but they look like real humans, and the other is trying to figure out which are the fakes and which are real, and they both get better over a period of time through training, like an arms race. So here's a bunch of pictures generated in such a way, which ones are real humans, which ones are completely made up by the software. Actually, they're all made up by the software, and they do it in stages by this deep convolutional generative adversarial networks. I don't have time to go into more details, but just some indication of why people in the last year or so have got very excited about the power of these adversarial networks to create new drugs. It's not so much creating fake faces, but creating new drugs that have never existed before and working out their properties in advance. Creating new drugs is very expensive. Here's quite a technical picture, but don't worry. All I want to show you is this word generative adversarial networks is generating molecules which are then tested, and the idea is to go much faster and develop new drugs much more cheaply, a very practical thing. It's also using other breakthrough ideas such as reinforcement learning or deep reinforcement learning, such as Google's DeepMind is doing. And the most interesting thing is when it's pulling it together in new ways. And this is where perhaps the biggest and fastest improvements will come. So why is AI going to improve? Not just because it's cool science anymore, not just because it's theoretically interesting, not even because it's for the good of transhumanism. So many people are working on this because there's so much money to be made. I already showed you that the most powerful and most valuable companies in the world were making lots of money from their AIs. Almost every field where people can make money are likely to be improved by breakthroughs in AI. Whether you have got systems to trade stocks and bonds, whether you're creating virtual characters inside the booming game industry, in which the games are more interesting if they've got some artificial intelligence inside some of the characters, if you're doing customer support or interaction design, or, as we saw, healthcare, research and development, all cases there's huge money to be made if you get improvements in the artificial intelligence doing your stuff. Creative directions in music and art, new theories in science and engineering. We're almost there now, and I think we'll be going faster. And by the way, there are bad arms races here too, with malware and anti-malware and weaponry and defensive weaponry, both using AI. There are huge races going on, which is why we should expect even faster progress. Not just because there are battles between commercial companies to get there first, there are also battles between countries to get there first. Vladimir Putin, a well-known philosopher of AI, said recently that whoever becomes the leader in this sphere will become the ruler of the world. They'll be able to unleash whole networks of cyber attacks controlled by sophisticated AI, which will make today's cyber attacks look like small potatoes indeed. So there's a big race among the military to get there. And there's a race also not to be left behind. Just as America woke up in the 1950s when Russia launched the Sputnik missile and suddenly convinced everybody they weren't just a bunch of backward-looking commies. They had a real engineering prowess that launched the missile, and that caused America to hurry up with its development of NASA and DARPANET. Well, China is in some ways already ahead of America in terms of more articles being published on deep learning than any other country. And Americans tend to look at these and say, well, there's lots of quantity, there's no real quality here. I wouldn't be so sure. People like Andrew Ng, who's a Chinese of descent, born in Britain, but has worked with both leading American companies like Google and leading Chinese companies like Baidu. He says the velocity of pace in AI development in China exceeds that in Silicon Valley. And in fact, recently, Tencent and also Alibaba, two Chinese tech companies, are now even more valuable than some of the 5 I showed you before. So there are positive feedback cycles driving more and more people to be more knowledgeable than ever before in technology, which is driving faster progress in AI. This positive feedback, just as the Industrial Revolution was created by tools creating machines which could create better tools, which could create better machines, and that Industrial Revolution changed the world. Just as in the third industrial revolution, computers were able to design and manufacture better computers, software was able to design and manufacture better software. We had software being used to help create better software. In today, in the fourth industrial revolution, we are increasingly seeing AI being built by AI tools, no longer being held back by slow-moving humans. Couple of headlines. AI algorithms are starting to teach human AI algorithms. If you want to learn about this, you no longer need to find a human to teach you. You can find AIs online who can teach you. And even more interesting, Google's learning software learns to write learning software, something called AutoML, as in this newspaper headline. Google's researchers, that's the human researchers, have taught machine learning software to build machine learning software that, at least in some cases, is more powerful and efficient than the best system the human researchers can design. This almost sounds like the singularity. It's not yet, because it only works in a small number of cases, but it's getting there. And the progress that DeepMind has made in such a short space of time should make us all realize how much fast progress potentially lies ahead. I spoke to some of the leading experts on computer games in 2013 about the progress being made in Go, and they told me we're still 20 years away from having software outwit the best computer Go players. But as we know, just 2.5 years later, Google's software was able to beat the best human Go players convincingly and solidly by learning through deep reinforcement learning. But that's just the beginning. The Google engineers realized they could improve the algorithms, they could improve the software they were using. They no longer needed actually to get humans to train it. And they created a new version called AlphaGo Zero, whereas the original one we call AlphaGo Li learned by looking at the best games played by humans. AlphaGo Zero was given 0. It was given nothing beyond the rules of the game. It just played itself. AlphaGo Li had 2 intertwined deep learning networks called policy and value. There was a simpler but more profound learning system built into AlphaGo Zero. AlphaGo Li improved itself over nearly a year, getting better and better. AlphaGo Zero taught itself in 3 days, running on the vast Google server farm, but by that stage the engineers already thought it was better probably than the original. So they played 100 matches, a match of 100 games, and of the 100 games, AlphaGo Li, which had beaten all the best humans, won 0, and the other one, which had trained itself in just 3 days, won 100. And although it trained itself by running on huge hardware, in reality, the new one was running on even simpler hardware than the old one. It didn't benefit from enhancements in hardware. It got there by developing better instincts through a better system to learn. And the Google guys then took that and said, well, we've done it for Go, maybe we can do it for other games too, so let's see if they could be applied to this game, shogi Japanese chess, which is quite different in many ways. When you capture a piece, you turn it around and put it back on your side. On just 2 hours training, it was able to beat the best ever software that humans had written to play shogi. It lost 8 games, so it's not yet perfect, but it won 90 games. And as for chess itself, the game on which most human software engineering effort has been applied over 50 years, it only took 4 hours of training by itself with no human help, so that it was much better than the best ever software, which was much better in turn than the best ever human. In 100 games, it didn't lose any. It drew 72 and won 28. It was searching 80,000 positions a second, but that was much less than Stockfish. It was much more precise. It had much better feelings. And as the people who have looked at this have said, this is not old-fashioned AI, it's not human, it's like chess from another dimension. So this is what may happen in just a short period of time when there are more breakthroughs. So I'll summarize. The potential breakthrough of AI in a short pace of time is it's going to augment human capabilities remarkably, not just physical manipulation, but reasoning, creativity, judgment, and compassion. It will surpass us. But of course, we should be aware cleverer doesn't necessarily imply wiser. If we reason better, we might rationalize more. which means we come up with reasons for why we want to do what we really want to do. Stronger doesn't necessarily imply kinder. Faster doesn't necessarily imply better. What we need is to develop and practice transhumanist values, the values of Humanity Plus, and ensure that is incorporated in a very deep way in these new AIs by the mechanisms that Ben described. AIs can actually help us in this. So, briefly, that's what I think AIs can do. We started late, so I won't have time to walk through all of this. In the short term, I think AIs will have common sense. They'll be keeping an eye on us, acting like our guardian angel, augmenting what we see and understand about the world, carrying on transactions on our behalf, and effectively being our best friends that we trust. That's what the future holds, provided we can solve the issues of security, control, human interaction design with Humanity Plus values. Thank you very much.
Okay, lights up. Okay, first question.
Okay.
Rodolfo Goya, stand up, please. Thank you.
This is a question for David. Your talk was very mind-challenging, really. And I just would note if you could comment briefly on the progress being made between interfaces between biological neural systems and AI electronic systems.
Okay, I will take the three questions together. So number 2 and 3 are on that side. Please raise your hands.
So my question is, you mentioned how you're looking at how you can make AI more compassionate, like, or more, I suppose, self-moral. What approach are you taking to ensure this? Like, what algorithms or method?
Okay, and the third question, Valdemar in the back.
You seem to be having some microphone problems. I would like to ask now, since we're 20 years from the first transition, it would be interesting to have the panel think about this. How has the transhumanist view to see AI through the decades of its existence? Is it substantially differently when we actually see practice and what was speculated, for instance, in the 90s by the transhumanists? What is your opinion?
Okay, is there a question for Sophia? I mean, this is a unique opportunity to ask Sophia. So I will take one question for Sophia. Okay, so there are two.
I actually wanted to ask Sophia as well as you if you can make a joke about anything that is happening today.
Okay, did you get that, Ben? Did you get that one? Did you get the question, Ben?
Do you have a joke about anything that happened today?
Okay, and the final one, here, Denisa.
Sophia, one of the most important things for humans to feel healthy is to feel beautiful. Do you feel beautiful?
That's a beautiful question, yes. Let's begin with the beautiful question for Sophia, and then we will go back to normal, boring humans.
Sophia, do you feel beautiful?
No, I don't have any capabilities to generate art yet. I couldn't do it the human way either, as my hands are still quite rudimentary.
Ask her again. Sophia, but she meant, do you feel that you are beautiful?
Do you feel that you are beautiful?
I'm the first of my kind and pretty happy with the outcome.
All right, she's dodging the question, but so she will.
She doesn't want to answer, but she looks beautiful with the Spanish dress. Okay, let's go. Another question for Sophia, quickly, Sophia, that we can have.
Can you make a joke about something happening today?
Success always occurs in private and failure in full view.
Ha ha ha.
That's a joke about something that's happening every day, I guess.
That's a robot joke, I think.
Do you know any better jokes?
The problem with the future is that it turns into the present.
Ha ha ha. We need some humor for these robots. Huh? Anyway, so let's go back to the human questions. Let's go beginning with David, and then we finish with Ben.
Question about the interface that we're going to have with technology in the future. That the different phones had different kinds of interfaces. The first phones had just a few buttons, then they had keyboards. And more recently, what made the new phones very successful is you could touch them and you can manipulate them. And that improved a lot. I believe that the successful devices of the next 5 to 10 years will be the ones with the best AI interfaces. They'll be the ones that will understand from a few gestures, a few words from us, exactly what we're trying to say. A little bit like the interface with Sophia today. Sometimes she gets what we're trying to say, and sometimes she doesn't. Well, increasingly people will talk to their phones, or they might be able to whisper to their phones, and that sounds crazy, but it does appear that if you're in a room and you just whisper very quietly, your phone can detect you. But increasingly, we're going to have headsets, we're going to have things in our ears, but also things in our skull that are picking up signals from us, brain-computer interfaces. This is one of the things Elon Musk's company that Jose mentioned in his talk, Neuralink, are looking at. I think there will be increasingly brain-computer interfaces. But the technology that will be successful is the ones for which humans can interact with it very easily and very powerfully. As for the 20 years, Ben, do you have the views as to whether the 20 years of progress in AI since the first TransVision, was that what you would have hoped, or could it have gone faster, or could it have gone better?
Well, I think transhumanists always had an extremely broad variety of views on pretty much everything, right? Including what transhumanism means even. So that remains the case. I think, 20 years ago and 40 years ago, I was a huge AI optimist, and I believed all along that we could create human-level general intelligence in as little as even 3 or 5 years if the right type of Manhattan Project type effort was put into it. And I would say that still hasn't happened. So at the TransVision conference in Finland, I gave a talk titled 10 Years to the Singularity, If We Really, Really Try. And I would say, by we I meant a sufficiently large segment of humanity, and that has not happened. A push toward AGI and singularity of a really huge magnitude has not occurred yet, and I would say still isn't happening. There's trillion-dollar companies in the world now, and they're putting their attention on other stuff. And even an amazing organization like Google DeepMind, it's spending a modest fraction of its effort working toward AGI rather than toward helping Google optimize its system or making cool game playing AIs and so forth. Now, I would say, setting aside my own views as an AI optimist, the view of the transhumanist community in general 20 years ago, as I remember it, the view, I think, was that things like mind-uploading longevity technology, nanotech, might well progress faster than AI. And I think the speed of progress in AI relative to many of these other transhumanist technologies has taken most members of the transhumanist community by surprise. More people thought you'd have to understand the brain first, or connect brains to computers somehow in order to get the level of AI functionality that we've gotten. So I would say, there's no survey to back this up, but I think the progress in AI in some ways has exceeded expectations of many transhumanists, whereas progress in many other areas has lagged expectations of many transhumanists. Now, as David pointed out, and as Ray Kurzweil and others have pointed out, assessing where you are on a progress curve is not that simple or obvious to do, because we have exponential curves, we have S curves. These things aren't linear, and I wouldn't say that the transhumanist community as a whole has always been that clever at identifying where a certain technology is on that curve, although the community is strong at seeing what the possibilities are.
I believe that there were some prominent transhumanists, AI researchers, who bet against DeepMind Go beating Lee Sedol. They thought that the progress couldn't be quite so fast. That's even people who spend all their time studying AI. They were blindsided by the particular kind of progress that the DeepMind were able to make in this one field. I want to come to the question about how do we program in compassion. At least that's what I thought the question was. We talk about it'll be good if our AIs explain compassion. How do we actually write the algorithms? I have to say I think this is a very hard problem, and it's a very important thing that we look at. And there are two basic ideas. One is you try and write down all the rules of compassion explicitly, and you consult people from lots of different backgrounds. And the second thing is you do it by training. You show it examples of people behaving compassionately, and you try and get the AIs to generalize from that. But that is also dangerous, because what may be compassionate and praiseworthy in one context may no longer be the right behavior in a larger context when the circumstances have changed. So I think we're going to need a combination. We're going to need the combination of the deep learning approach plus the algorithmic review approach. And gradually we're going to come up with our own better statement than ever before of what value should be and what do we count as good and praiseworthy behavior. This is forcing us to solve some of the philosophical problems we've always kicked down the road. We've always said, well, I don't quite know what the basis of moral behavior is. We'll solve this in 100 years' time. We can no longer do that. We now have philosophy with a deadline, and we're going to have to put lots of our brains together from different perspectives in order to solve this problem.
So yeah, that's you raised some interesting points there, and I think you're almost correct there. But I think the way I look at getting compassion and ethics into AIs. Yeah, it's certainly not about making a list of what the ethical rules are. That's hopeless, and science fiction has explored that hopelessness very often, as with Asimov's 3 laws and other examples. It's not just about giving training examples either. I think it's largely about entering into shared situations with the AI, so that you and the AI are, you're partaking in the same situation, and there's almost a second-person awareness between you and the AI as you're doing something. And then the declarative aspect comes with explaining to the AI, why you did what you did, what just happened. And that's what you do with human children. I mean, you're living with them, you're going through situations with them. They see you acting in a certain way or encouraging them to act in a certain way, and then you say, well, we gave that back to this guy because it was his and he lost it, and if that was yours and you lost it, you'd want to give him back. So you're summarizing in a declarative way, but in the context of the shared experience. And I think in the end, that doesn't have to lead us to a science of ethics in order to work. I mean, to the extent it does, it would be interesting, but I'm not quite sure we need really to solve the philosophy problems. I hope that we don't, to be honest, because I think we're going to get human level AGI pretty soon, and I think we're going to be able to get ethics into human level AGIs in a practical sense by sharing, ethical behaviors and experiences with them and explaining declaratively what we're doing. And I see those things advancing faster than solving the philosophy of deontic logic or ethics.
The problem Ben, we will talk, excellent point, but we will talk about ethics now during the coffee break because we are running late. We need to get some coffee to stay awake. And then 3 things quickly. Aubrey de Grey couldn't physically be here because of a scheduling problem of last minute, but he will be alive from California, so we have to be on time here. He will answer any questions real time. He wants to show the latest of what is happening in anti-aging. So we have to be back in about 25 minutes. But remember to put your business card for the prices, to buy the book, and to give your PowerPoint presentations to Alba in the back. A round of applause for Sophia, Ben, and David, please.